All right, this is the equilibrium class practice. Use this to review what we did in class yesterday before completing the equilibrium quiz. So kind of our fundamental, equilibrium fundamentals. So if we have a reversible reaction, initially we only have reactants, we don't have any products yet. And the rate, which means that the rate of our forward reaction is high. The forward reaction is kind of that normal reaction where we read it left to right. And we don't have, since we don't have any products, that reverse reaction isn't going to be able to take place. Eventually, products begin to accumulate, so we have more products, and our reverse reaction can start to, the rate of that begins to increase, and in doing so, the forward reaction rate is going to decrease. And so when those rates become equal, that is when we've reached chemical equilibrium. So the exchange between those is equal, which means the amounts of products and reactants are going to level off, and they're going to stay constant and are no longer changing. The amounts don't have to be the same, but whatever the concentration is for that specific product or reactant, its concentration is going to stay consistent. And so that forward reaction, we would just write with our reactants on the left and our products on the right with our arrow going to the right. Our reverse reaction, we're just going to take those products and they are going to become our reactants with our old reactants becoming the products. We can write equilibrium expressions based on these reactions, and those are going to help us determine what might be favored if we have concentrations of each, so we know how much we would be using. So with that equilibrium expression, our KEQ expression is the concentration of our products over the concentration of our reactants. So KEQ is conservation of products over concentration of reactants. And so when we look at this KEQ expression for this first reaction that we were given, why don't we have anything in the bottom? Well, we have our 2KOH. Well, we have KOH concentration squared. That 2 is going to become a coefficient, or that coefficient becomes an exponent. And then we have that hydrogen concentration. But because we have a solid and a liquid, those concentrations can't change. And so those aren't included in our KEQ expression. What does the magnitude of our KEQ tell us? Well, it's showing that ratio of products to reactants. So our KEQ is products over reactants. So if our KEQ is 10, that's like saying 10 over 1. That means that whatever's in the top, my products, is going to be favored. And so I would have more products than I have reactants. And so this would be something with a KEQ of 10 would be product favored. If we have a KEQ of less than 1, then that means that whatever was on the top was larger, whatever was on the top is smaller because we're dividing by a larger number, meaning whatever's on the bottom, which would be our reactants are going to be favored. And so I would have less products, more reactants, and this is a reactant favored equation. We're just showing that space. So if something's favored, we're showing that there's going to be more of that. You might demonstrate that in a little bit different way, but just showing there's more reactants than products once we've reached equilibrium. So these KEQ expressions, if we have a reaction and we're writing our KEQ expression, our KEQ, we do the concentration of our products over the concentration over our reactants. We need to make sure those are things that can change concentration. So as I look at this, Sodium chloride, nope, barium chloride plus sodium sulfate produces barium sulfate and sodium chloride. Well, barium sulfate is a solid, and so that's not going to be included in my equilibrium expression. It's not going to be able to change concentration. And so my KEQ expression of my products, only sodium chloride is going to go in the top of my expression. So I'm going to have the concentration of NaCl, but I have 2 moles of it, so I'm going to need that squared on the top, over concentration of my reactants. So then my reactants are barium chloride and sodium sulfate. So then I'll have my BaCl2 times concentration of Na2SO4. In balancing, we only have 1 mole of each, so these don't have any exponents. And then we're provided concentrations. So molarity is the only unit we're going to use for concentration in this unit. And so having those concentrations, we can now plug those in to calculate what is that KEQ value going to be. So my NaCl, that has a concentration of 0.4 molar. I need to make sure and square that because that was in my expression. Divided by concentration of barium chloride, 0.67 times 0.23. Make sure you know how to do that in your calculator. We are going to divide by 0.67 and by 0.23. And because each of those had 2 sig figs, we're going to have an answer with 2 sig figs. I got 1.9 is my KEQ. It doesn't ask us for this, but what's favored, because this KEQ is greater than 1, that means that my products are favored. So my products are favored because the concentration in the numerator was greater than the concentration down here. All right, so putting all this together, if we go ahead and write a reaction, feel free to pause this if you would like to write the reaction on your own.
Attention students, once again, the B and C buildings need to be cleared out at this time for the speech meet. Please make your way to the A building to wait for your ride or exit the building at this time. Once again, the B and C buildings need to be cleared for the speech meet. Thank you.
All right, I've tried to record this video multiple times, so I'm not going to re-record it because they keep making announcements. All right, from my reaction, aluminum has a +3 charge, carbonate has a -2 charge, so we do our drop and switch to make sure that's neutral. 3 carbonates, 2 aluminums. Putting in our states of matter because that's going to determine what goes into our KEQ expression. And same thing, aluminum +3, oxygen -2. Balancing that out. So writing our KEQ expression, well, KEQ is products over reactants. I have 2 solids, so those are not going to be included in my expression. But my aqueous CO2, that's a product, so it's going to go in the numerator. CO2 cubed over nothing, or I'm not going to put that aluminum carbonate into my KEQ expression because it's a solid. So you can either just leave that with no denominator, but that is over 1. And so if we're going to, we wrote the expression. So now if we are going to determine what is our KEQ value, let me look at what it gave me up here. You have 0.475 moles of carbon dioxide gas. So that's how many moles of gas we have. And the reaction took place in a 4,600 milliliter container. Well, we need these square brackets mean concentration. So we need to find what is the concentration of our CO2. And concentration is moles per liter. So we can take the 0.475 moles of CO2 in liters. the milliliters, we're gonna divide by 1,000, so 1, 2, 3, 4.600. I'm not gonna put those there because of sig figs, liters. And I get 0.103 molar. Then I can go and plug that into my KEQ expression. So KEQ equals that CO2 concentration cubed. So 0.103 cubed, which gives me 0.0010 is my KEQ value. Looking at this, 3 sig figs, 2 sig figs. So at the very end, I'm leaving 2 sig figs. No units on KEQ values. And because is this product or reactant favored? Well, our KEQ is less than 1, meaning that it's favored by whatever is in the denominator. And so it is reactant favored. All right, take some time to do any other reviewing you need, and then you are off to do the first quiz for the unit.